true projects. In this video, we are going to explain about the project that is effective identity authentication based on multi-attribute centers for secure government data sharing. Before getting into the execution first, let's understand what is the project about. In today's world, data is more valuable than ever. It is the driving force behind innovation, efficiency, and better decision making across all the sectors from businesses to the government. Government in particular, they are working hard to create systems that makes it easier for different departments to share the data with each other. The kind of sharing is crucial for providing better services to the citizens and making more informed decisions. But despite its importance, secure and efficient data sharing isn't always easy. One big problem is that data is often stored in different places, makes it harder to access and share. On top of that, there are always risks of unauthorized access to sensitive information. And ensuring that the right person is accessing data is a constant challenge. Identity verification is critical part of making sure that only authorized users can access certain data, but it is not always simple to implement securely. So these issues makes it tough for governments to fully utilize the potential of data sharing systems. Traditional identity authentication systems that are quite common because they are easy to implement, but they come with the risk. One of the biggest issue is that they rely on central server to manage everything. If something goes wrong with that server, like if it is attacked, it can bring down the entire system. This is called single point of failure, and it leaves the system vulnerable to majority security breaches. And additionally, the other problem is that these systems store sensitive user data in a one central place, which increases the risk of privacy leaks. If someone gains unauthorized access to that data, it can lead to serious breaches, exposing personal information. And when things do go wrong, it is difficult to figure out who is responsible for that. So, this makes it harder to track down the source of a data breach or unauthorized access. Because of all these problems, it is clear that a more secure and reliable way to authenticate identities is needed, especially when it comes to handling important government data. So, to overcome with all these issues, this proposed system is designed to fix the issues that come with the traditional centralized identity authentication, especially in government data sharing. So, instead of having everything controlled by a single server, so the system uses a decentralized approach, that is blockchain and the interplanetary file system, that is IPFS. So, here we are using blockchain and IPFS to make things more secure and efficient. So, Blockchain is essentially a distributed ledger. We call it as distributed digital ledger technology, which allows the data to be stored in a one way that is transparent, secure, and that cannot be tampered with anybody. And this makes it perfect for verifying identities because it ensures that once the data is entered, it is it is there to say that it can't be changed by unauthorized parties. And and to keep the things lightweight and secure, the system uses ECC, that is elliptic curve cryptography, that we call as ECC for key generation. So this ECC is used for key generation and encryption. This method ensures that sensitive data like the requester's name, contact information, and department stays protected. Once this data is encrypted, it is stored in IPFS, that is called interplanetary file system. It is a system that helps to manage and share files efficiently. And IPFS generates a unique hash code for the data, which is then stored on the blockchain. This way, the data can always be verified in the future, ensuring that the requester's identity remains secure while reducing the storage cost. And the system decentralized approach removes the risk of depending on a single point of failure. So, here, this blockchain is of decentralized nature. So, this removes the risk of depending on one single point of failure, which is a big issue in traditional systems. So, by spreading out the responsibility and control, it becomes much more resilient and it prevents the unauthorized access. And blockchain smart contracts play a key role, thereby securely storing hash codes of the encrypted data, ensuring that the data stays intact and cannot be tampered with. What is cool about this is that it allows for transparent identity verification without revealing any sensitive details. And we have also used Ganache and MetaMask. We have also integrated the tools that are Ganache and MetaMask, which helps in developing and interacting with the Ethereum blockchain. So the combination of IPFS for cost-effective storage and blockchain for secure, unchangeable verification creates a powerful and efficient system. So essentially, this setup provides a strong privacy focused solution for government departments to share the data securely, efficiently without compromising sensitive information. We have noticed that relying on basic citizen details like name, contact number isn't always enough to ensure proper authentication. So, as an extension to make the system more robust, here we are adding an additional requirement for citizens to upload an address proof document. So, this extra step helps in verifying the authenticity of the citizens more accurately and makes it easier to distinguish between genuine users and fraudulent ones. And as a second extension, we have realized that current use of ECC, that is elliptic curve cryptography, is quite heavy in terms of computation and storage, which isn't ideal. So to address this, we are replacing ECC with the Cha-Cha encryption technique. So here we are using Cha-Cha encryption technique along with ECC. So it is much lighter and it reduces the system's computational load and lowers the storage cost while still maintaining the same level of security for key generation and also encryption. Together, these extensions enhance the system's efficiency and strengthen its authentication process. And to implement this project, we need basic requirements. Coming to software, we need Python, ideally Node.js, Visual Studio Community version, Ganache, MetaMask, which is the Chrome extension. And backend languages are Python, JavaScript, Solidity, framework is Django. Frontend languages are HTML, CSS, JavaScript, and Bootstrap 4. And hardware are processor of 5 and above, RAM of 8 GB and above, and ROM of 20 GB and above. So now let's execute. To execute, we are supposed to open the code folder that contains source code files. So let's open that. So these are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? So here in this contract folder, we have Solidity code. It handles data structures, functions, and events with modifiers for validation. Now let's open this identity authentication folder. So here in this authentication folder, we have Python code files that are intended to be dynamically loaded into the project code during runtime. And this authentication app folder, in this authentication app folder, we have two subfolders and some Python code files. And subfolders are static folder and templates folder. In static folder, we have files related to CSS, JavaScript, and Bootstrap files, which are important for visual appeal and interactive aspects of the application. In templates folder, within that folder, we will find all the HTML pages used throughout the project. It includes pages like index.html, home.html, and more, representing various sections of the website. And we also have some Python code files that will be executed during the runtime of the application, supporting its functionality. And this is the JSON file. This is the SQLite 3 file in which user details will be stored. And this is the manage.py file. So this is a command line utility that comes with the Django, and it provides various commands for managing Django projects, including tasks like running the development server, creating database tables, applying migrations, and more. And this is the IPFS BAT file, that is the interplanetary file system. So by double clicking on this, IPFS server will be hosted. So first we need to double click on that. So now IPFS server will be hosted. So it has been started. I mean, IPFS server is started. Let's minimize this. Now we need to host the blockchain server. For that, open Ganache. So open Ganache. So select the workspace. And here server is hosted. Now let's see how many blocks we have in the blockchain. So initially we have just 4 blocks. After execution, let's see how many blocks will be created in this Ganache. Let's minimize this. And now double click on this run server.bat file. It is the Windows BAT file. Instead of running the project through command line interface, we have created this Windows BAT file to execute the project. So we need to double click on it. Here manage.py file is compiled. And now the Django framework will host the application locally at the default address, which is the local host and the port. So this is the local host and the port. Now copy this local link provided by the Django framework and paste it in any web browser. I'm copying it. Now open any browser. I prefer Chrome, so I will paste it in that. So paste the link here. Click on. Now type index.html and click on enter. So this is the web page of the project, which is displayed in the browser. So here we can see various links, right? Admin login, data owner or requester login, and register here link. So before registering and doing all the activities, let's check how much of the ETH we have in the MetaMask wallet. So open the MetaMask wallet, which is the Chrome extension. Give the password. Now click on unlock. So it has been unlocked. Here in our MetaMask wallet, we have 99.99 ETH. Now let's do some transactions and see how much of the ETH we have in the MetaMask wallet. So here the procedure will be, so data owner will be get registered, data requester will be registered, and admin, he will be able to add the proofs of the data owner, and requester, he will request for the proofs, request for the details of the data owner. So now let's get registered as data owner. So click on register here. And now we are supposed to provide all these details of data owner. So let's enter username as Kiran and give his password, give the contact number and give his mail ID and give his address. And we need to select data type as user type as data owner. And now we need to click on submit. So here we can see that all the details of the Kiran are successfully added to the blockchain. They are securely stored in the blockchain. Let's see how it has been stored. So let's open Kanash. And you can observe that there are total 5 blocks. Initially, we had only these blocks, right? So here this 5 blocks has been created. Fifth block has been created. You can observe, right, at which time that particular block has been stored. So we have added it recently. So that is why it is showing this time. That is 6 p.m. 5 minutes it is. So let's click on this block 5. And here this is the block hash. This is the transaction hash. Click on transaction hash. And this is the sender address, to contract address, gas used, gas price, gas limit, and transaction data. Now let's do some more transactions. Let's get back to the application. So now let's sign up as the data requester. So the username would be Kishore. Give his password and give his contact number and give his mail ID and give his address. Now select the user type as data requester and now click on submit. So the details are successfully added to the blockchain. Let's open blockchain and you can observe that total 7 blocks are created. Now let's log in as admin and add the proof of the data owner. So click on admin login, give the username of the admin. Now click on login. We have logged in as admin successfully and here we can add the owner details. Admin will be able to add the owner details. So click on add owner details and here we need to provide all the details. So here owner name is Kiran. Gender is male. So here we are supposed to provide the contact number, give the mail address, and here we need to provide the Aadhaar number of the Kiran. So let's provide the Aadhaar number. So we have given the Aadhaar number and now we need to click on choose file to upload the address document. So click on choose file. So we are supposed to upload this for example. So I'm selecting it. Now click on open. It has been loaded. Now click on submit. So you can observe that owner details are saved in the blockchain. So here they are saved in the block number 8. Let's open Ganache and see. So here you can observe, right, block number 8 has been created in which the address proof of the data owner has been stored. Let's get back. So these are the details of that particular block. And now let's see, click on view owner details. So click on that. So these are the details of the owner. And here if we click on download file, admin will be able to download that file. So let's click on download file. Here you can observe, right, that document which admin has uploaded recently has been downloaded. Now let's log out and log in as requester, that is data requester. So provide the details of requester, username and the password. Now click on login. We have logged in successfully as data requester. Now we are supposed to click on access owner data to get access, to download the details of the data owner. So click on that. So these are the details of the data owner. So here we can see the data owner is Kiran, gender is male. This is the contact number, email ID, address, Aadhaar number, document name. And here if we click on download file, the data requester, he will be able to download the file. So here data requesters would be any of the government authorities that they want to get the details of data owners. So now let's click on download file. So here you can observe, right, the data has been, the address proof of the data owner has been downloaded. So in this way, data requester can get access of the data owner. Now click on log out. So before logging out, let's check the computation graph. So click on computation graph. So here, this is the computation graph. Here on x-axis, we have the algorithm names using which the data which is uploaded has been encrypted. And on y-axis, we have computation time. So the proposed model, that is ECC algorithm, is taking much time than the extension model Chacha 20 algorithm. You can observe, right? Chacha 20 is taking the less computation time to encrypt the data. Now let's log out and log in as data owner and see who has requested for his data. So let's log in as Kiran. Now give his password. Now click on login. So he has logged in successfully. Now let's click on view requester details. So here we can observe that requester Kishore has been requested for the details of Kiran. You can observe, right? So Kishore is the person who has requested for the data of Kiran. So with this hash code, requester, that is requester multi-attribute blockchain verified hash code, we can understand that the data requester Kishore is a verified requester. So the details, data owner's details are safe. Now click on logout. So this project enhances secure data sharing by adding address proof verification for accurate citizen authentication and replacing ECC with lightweight Chacha 20 algorithm, reducing cost and complexity while ensuring strong security. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.